So once again, thank you all for sticking with us. I know it's a bit late. I was expecting and maybe hoping for a couple of more people in the crowd, but we will still do the exercise that I planned. So how many of you are using Kafka? Okay, nice, kind of. Good. Okay, half. How many of you know what data governance is? Okay, half again. And how many of you think that data governance is important? Everyone. Yeah. Okay. Okay, still half. So, my name is Ivan Dundovic, and I work at CROZ as a data engineer. And today I will be talking to you about data governance and how we applied it on event streaming systems in some specific stack that most of our customers use. For a short motivation, something that is really important, and even on this conference we heard on many talks that people had problem with, is data quality. It's quite a big topic. Everybody is talking about it and saying that their data quality is bad. Unfortunately, not all organizations are taking care of it, but at least everyone knows that they have problem with it. That's a good start. A lot of organizations from time to time are struggling with answering to questions related to where data resides. In AI world, for example, data scientists want to use some data, and when they look in the organization for the data they need, they often have problems because organizations don't have this data cataloging and similar technologies and processes in place. Besides looking for data for some analysis or other things that you are doing, it's important to know where your data is when GDPR and other regulatives are in place and need to be enforced. When it comes to streaming, things get even more complicated because data is generated very fast and we need to act on it fast. One specific problem in streaming, for example, that is very common is that often you will see streaming applications that have no clear schemas defined, and that can be quite a big problem. Also related to that problem is when one application changes something, writes some data to Kafka, and then that breaks a lot of other applications. It's not only a theoretical thing, it really happens in production to some of our customers. And that's all of these things that I showed on previous slides are not something that I came up with just for the sake of this presentation. These are actual things that we heard from our clients and that we helped for our clients to resolve these problems. So over the course of 15 years that we are doing data at CROZ, because this is not the only thing we do, we have over 300 engineers working as Java developers, DevOps, sysadmins, mainframe guys. We do a lot of things. But in data, we've seen these problems 15 years ago when data warehouse was main thing, later with data lakes, and today in streaming and AI world. I will focus today not on data warehouse in these topics. I will focus on data governance in streaming and how these things can be brought together. Okay, this looks really nice on the slide. I was a bit worried that it will be stretched, but it is really nice. I hope you agree with me. We will go through the presentation as a story, and in our story, we have our customer on the left side of the screen, and this customer has problems with data quality, data lineage, and data catalog. In general, this customer is not happy with data situation. We will help our customer overcome classic data governance obstacles, so data lineage, data quality, and data catalog, and help him to enter the land where data is clean. So first obstacle is data lineage, and all of these obstacles we will try to solve with our most important tool, data governance. Data lineage is an important topic in data governance, and we use data lineage to answer questions like where data is residing, where it is coming from, and where it is going. So for example, we can imagine a situation where we have hundreds or maybe thousands of microservices that can be Java applications, for example, that implement some business logic, but they communicate with each other over Kafka, for example. So they are sending some messages through Kafka. And we can ask ourselves, what are the all applications that are using messages, so consuming messages from some particular Kafka topic? If we don't have a proper data lineage in place, that can be quite hard to answer. With data lineage and using data governance tools that implement this data lineage, we can even visually really easily get answer to these kind of questions. On this slide, we have a screenshot from Apache Atlas, which is just one of many popular data governance tools. And Apache Atlas has a couple of functionalities. Data lineage is one of them that is implemented in Apache Atlas. So what we see on this slide is, if you look on the right side of the screen, we have this auditor process. We can think of it as a Java application. What we are also seeing here are with all these lines is basically the lineage of all Kafka topics and other processes that are having impact on this application. So if you go from our application on the right side, we can see that it's using Ranger audits, Kafka topic, metadata, collector entities, etc. And we can also go not only one level behind, we can go all the way from the beginning of our data, where data was created, and see the entire lineage, the entire path that it went through, and how it, in the end, entered our application. Cool. With Apache Atlas, we solved our first problem, data lineage. Now, we are moving forward to one very, very big topic, and as I mentioned earlier, very important topic, data quality. I will speak only about a very small part of data quality, because it's a huge topic and we can talk for hours about it. And I will focus on one thing in Kafka, one feature in Kafka, that is for some things good, but for some things bad. And that is that Kafka doesn't care about the content or semantics of data that we input in Kafka topics. So for example, in some Kafka topic, we can write a set of bytes that is just a random set of bytes that doesn't have any particular meaning. But we could also send a set of bytes that, when deserialized, represents a well-structured JSON. Kafka wouldn't care. It's just receiving and sending bytes. And that can be problematic, because if we don't have a proper data governance in place, and if you don't think about these kind of problems, we can get a lot of trash in our system. By using schema registry and some modern data formats like Avro, for example, we can help ourselves in solving part of these problems. So now, on next slide, I will give a quick introduction to schema registry, how we can use it to solve this problem, and what is our motivation for that. Maybe I will start with explaining what schema is. So, as I said, we can send anything to Kafka. One very popular data format for the last 10 years, I'd say, is called Apache Avro. Apache Avro is a project that started back then when Hadoop was the thing. And the motivation is to bring schema to data so that, for example, when we have some CSV file that doesn't have a clearly defined schema, so, okay, now you can say, but CSV file has column names. Yes, but we don't know anything about data types, for example. So with Avro, we basically combine schema that we can represent in JSON together with our data. And then whenever we send this data, we are sending the schema with that data as well. So that's how it started. Now, in streaming and in schema registry, all these principles apply. There are some optimizations that were added later for the purposes of streaming. But it is a really nice thing because now when we are sending data through Kafka, we know what the schema looks like. And schema registry plays a crucial role there because in schema registry, we are storing all our schemas. So when a producing application is producing some data, it needs to serialize that data. And if this data doesn't conform to the schema, it will break. So once the data is, our message is properly serialized, it is sent to Kafka, and then consumer can communicate with schema registry, retrieve the latest version of schema, and successfully deserialize that data. So if that schema registry is not used, what can happen to us is that some producing application introduces some change that will break the schema, it will break compatibility, and then eventually it will make mess on consuming applications. There's a lot of other things that we can talk about in schema registry. This particular image is taken from Confluent. It is a company that mostly contributes to open source Kafka, and their schema registry is kind of a standard when it comes to schema registry, even though there are many other schema registries that you can use. This, as I said, will not solve all our data quality problems, but at least it will help us in documenting stuff, so we will know what schemas our applications are using, and it will help us with preventing a lot of applications breaking because of these reasons, and also it is nice because we are helping ourselves in preventing at least some garbage entering our Kafka. Okay, we are progressing very well. Two of three things solved. Last but not least, data catalog. And this is also a very big topic. And I guess that you heard about term data catalog because it is very popular in data world. And what data catalog does, it helps us to have a catalog of all data assets that we have in our organization. So, for example, for data scientists, as I mentioned earlier, they can easily search through data. We can, when, for example, audit comes into our organization, we can easily show them where are all PII, GDPR sensitive information stored. So it is a really, really useful tool. And even on this conference, for example, on Bosch talk yesterday, we could hear that they have many data catalogs since they are a huge organization, and they are putting a lot of effort into making one big data catalog of data catalogs. So all companies are using it, or at least they need it to some extent, from small to large enterprises. Okay, sorry, just so that you can read this last slide, but I don't follow slides very often, so sorry for skipping this. But important thing that I wanted to show you is on this slide, and that is a screenshot also from Apache Atlas. So Apache Atlas, as I mentioned, implements a couple of different things. Two of the things that I mentioned here, data lineage and data catalog, are the most important features of Apache Atlas. And what we see on this slide is one Kafka topic. So this Kafka topic is called CDC PII anonymized. What I didn't show here is from the home page of Apache Atlas, we can search through our assets. So we can search by asset type, we can search by name, we can search by some tags. So let's say that I wanted to find all PII safe assets. I could do a search on PII safe classification on home page because I added this PII safe classification to this Kafka topic before. And I enter inside of this asset. And here I can see some properties. On the next tab, you can see that we have a lineage here, and we saw that before. And in these properties, what we actually want to do in data catalog, besides cataloging names of our assets, we want to catalog all metadata, not only business metadata, but also some technical metadata, if we feel that it is important to have that. And in real systems, it can be quite handy to have that technical information as well. So that's why I pointed out some of the technical information here on this slide. Also, our schema, so name of our schema, or even maybe we can put in columns. Apache Atlas has some default things that you can use, some default features, but it's open source and it's very easy to add new asset types or extend it for whatever you want to use it. And that concludes these three very important topics. And now we can ask ourselves, okay, but did it really solve all problems in data governance, with data governance in streaming? So how did we come up with all of this? As I said, we have a lot of customers that are using different stacks, technological stacks. And all our customers need data governance, have it to some extent, or don't have it at all. So we took all of these technological stacks that our customers use, and we said, okay, most of our customers use Kafka, most of them use schema registry as well, most of them use Atlas as data governance tool, and they use Ranger for security. And that is perfectly fine, very popular stack, I'd say, but what is missing is that Apache Atlas is our main data governance tool. And as such, it's missing this near real-time component. So we came up with a simple Java application that glues all these applications together and brings near real-time features to Atlas. We named it CROZ Auditor, but you don't have to bother Googling it and how much does it cost, etc., because we are not selling it as a product. We just gave it a name so we can talk about it on presentations. But you can't buy it. That's it. You can reach to us if you need help with data governance. Maybe CROZ Auditor will be a helpful solution. Maybe something else. We try to be technological agnostic. Now we will look at this stack and how data flows and what these applications are exchanging between themselves. So we have Kafka, and on Kafka we have a bunch of applications. We can think of it as Java applications, Python, microservices, whatever. And they're using Kafka as a main message brokering system. Apache Ranger is used for security. So we define access policies in Ranger, but it also has auditing features. So whenever some application tries to consume from Kafka, create new topic or anything, all of this will be registered in Apache Ranger. Of course, these access policies will be enforced. So if some application that doesn't have access to some topic tries to access it, it will be denied and it will be logged. Schema registry is used for the purposes that I mentioned earlier. Apache Atlas is main data governance tool, and it serves purposes of lineage and catalog. And one really nice feature that we are heavily using in all projects is tags. So this classification PII safe that I showed earlier, we can sync these tags between Atlas and Ranger, and then in Ranger define policies based on these tags. So if we have a new topic and we know that it contains PII safe information, we add this tag, and this automatically gets synced with Ranger. So all users, all applications that don't have access to PII safe data assets will be forbidden to access it. And as I said, this looks really nice, but one of the main problems is that if we want to have all our Kafka topics registered in Apache Atlas doesn't have a functionality to refresh this metadata in real time. We need to trigger that manually. And we don't like that. Well, at least I don't like it because I love streaming. So if we can automate something and make it near real time, we will do that. And that's why we introduced CROZ Auditor. So what CROZ Auditor actually does is audit logs from Kafka are constantly read, and if this application auditor figures out, oh, look, here's the topic that I haven't seen before, and this topic is created, I will automatically send that to Apache Atlas. And as I said, Apache Atlas is extensible, and we can do whatever we want with it inside. So we create this new, topic. We edit whatever metadata we want to add to that topic. Lineage is automatically created, and that way we have basically near real-time refresh of our assets and metadata in Apache Atlas. Besides looking into audit logs from Kafka, it is also connected to schema registry, so it will also look for new schemas and register these schemas in Atlas. So we have everything covered when it comes to Kafka and schema registry to put this information in our data governance tool. And we were very happy that governance once again solved our problems. So to wrap it, as I said, we try to be technology agnostic. We have customers that are fully on-prem, ranging from 5 servers in production to 100 servers in production. Huge systems that are really hard to maintain. And this customer, for example, that has 100 servers and petabytes of data, for them, it's really important to know where data is, and data governance is crucial for them. But we also have clients in cloud, full in cloud, partial in cloud, hybrid cloud, multi-cloud, whatever. And our mission is to help our customers with all data-related problems. So CROZ Auditor is one application that helps some of our customers, but for other customers, it will be something else. There are many popular data governance tools: Open Metadata, Atlan, Data Hub, there's, I don't know, 30 of them, something like that. And we constantly keep track of what is new in that field. We do internal R&Ds so that we can always give our customers the best solution that fits their needs. My name is Ivan Dundovic. As I mentioned before, this is a QR code for my LinkedIn profile if you want to connect. And thank you for being here so late once again, and I hope you enjoy it.
Thank you, Ivan. Do we maybe have some questions? Yeah, we do. Great. Even though we're in this intimate atmosphere, I'll bring you the mic.
Thank you. My name is Mikhail. I'm new to streaming technologies. So at the beginning of the talk, you mentioned that the main problem is when you have the consumer that is like accepting some specific topic, but somehow that message schema for this topic is changed, so consumer may be broken, right? But how your tool help with this problem? Because I didn't find this in the last schema.
Okay. Yeah, so I will go back to that slide. So CROZ auditor doesn't do anything it doesn't interfere in a schema registry or anything schema registry does. What it does, it pulls information about these schemas from schema registry and brings that into Atlas. I didn't mention that, but by default, Apache Atlas doesn't have support for schema registry. So these schemas will not be in Apache Atlas. So what we did is with Auditor, we pull schema from schema registry and bring it to Atlas because we want to have these schemas in Atlas along with our Kafka topics. So yeah, that's what Auditor does. Otherwise, we will have just the names of our topics in Atlas, but without schema that it is used for that topic.
Okay, but is it the often case when that schema for some topic is changing?
Yeah, very often. But there are rules. So that's why I said that there's a lot of things that we can talk about when it comes to schema registry. So usually what you do, you have three compatibility types: backward, forward, and full compatibility. So that means there are rules that you need to follow. So for example, if you want your consumers to still be able to consume new data with changed schema, but if they have old schema in place, there are certain rules that you need to follow when you change your schema. And if you do some change that breaks this rule, schema registry will deny this new version of schema. So that is really, really important functionality of schema registry because it does this validation. If you say, okay, this topic will be backward compatible, schema will be backward compatible, it will deny registration of new version of schema if you introduce breaking change.
Okay, makes sense. And there is some versioning for schemas for this topic, right?
Yes.
Okay, cool.
You can, as I mentioned at the beginning, send any data you want to Kafka. Schema registry will not help you there. But usually, what is recommended is that you use one type of schema, one schema for one topic. Otherwise, you will have a lot of problems. So
yeah, I understand. But let's say if we change the schema, but later data scientists want to extract this data, they need to understand what schema used for specific timestamp for the data set, right?
Yeah, that's true.
Okay, thank you.
Do we have some more questions? No? Okay, thank you guys. Thank you, Ivan.
Okay, thank you.
High five.
Thank you.
Okay, we have officially closed stage 2. We've come to the end. Thank you very much. Maybe we can join the main stage just to see the closing talk. And thank you for being here, and I hope you enjoyed it.